right, welcome back to the Application Binary Interface Part 2. Now, if y'all recall, I mentioned how I actually made my own PDP-8 model and working computer in a virtual game known as Second Life. Well, here it is. This is what it looked like. And it actually worked. So with that, this is where we're at. And here was the original PDP-7. And take a look at it. Click here, and you'll notice PDP-7. This silver box right here was the PDP-7. All right. So yeah, we used to play with that stuff back in the day. Now, what's this all about? Well, it's about calling conventions. That's really what the ABI, or Application Binary Interface, is all about. When it came to assembly language, you didn't really have an interface. You didn't really link at all. You didn't link files. Not in the traditional C way that we do now. So when it came to using C, there were problems when it came to OS programming because we needed a standard. We needed ways to allow different kinds of programmers to be able to use C and come together and align software from maybe their library or maybe their executable versus your executable or library. So the two different pieces of software made by different people would still be able to talk to each other. This is why you can make a program in Windows and it works in Windows libraries, even though you didn't make those libraries. So that is why the C calling conventions suddenly became a thing. And ABI was born, Application Binary Interface. So this right here is the one that Linux uses. System V, x86-64. We won't get into the 386. That's old school. We don't need to worry about that. But these two right here, this is prominent. This is what we're talking about. And the reason I don't use Sys V is because it's non-standard. The UEFI or EFI, which brought out here, you can actually look up in the official specs from the UEFI website, grab their official UEFI specs 2.9 or _9, go to page 27 and read this section here. And it actually talks about all functions are called with the C language calling conventions. And you can actually look up more about how all this works in the actual official Intel specs. Let's see here. Scrolling down, it talks about the 128 kilobit of available stack space, how the stack must be 16-byte aligned, and let's see here. We are in long mode at this point. And as you read in here, you'll start to figure out how certain things come to be. Floating point control must be initialized to this. That might come in handy for us later when we need to know this. Multimedia extensions control word must be initialized to that. So that's another thing we might need to know later on. These two are set to 0. And that, again, we'll come back to later. For operating systems to use any UEFI runtime services, it must, and here's all the info that it needs. And as you scroll down and you're going through all of this, you start to realize, wow, this is a lot more than we realized, than we knew, right? Well, the handoff state means going from the hardware to the EFI software. And by the way, in our tutorials here, UEFI TUTS, we are actually creating the software interface that comes from the hardware's firmware to our actual UEFI bootloader, or in this case, application. So we are creating an application from scratch if you follow the UEFI TUTS series. The handoff state is these two registers here, which, as you'll notice, EFI handle and EFI system table, and you'll recognize those by any of the actual tutorials when we go to actually look at these. And voila, scroll down, and bingo, there we are. We've got the EFI handle, image handle, and EFI table, system table. So in retrospect, or when you actually compare that, here, let me close this. When you compare that with this, and you'll now know that the assembly language registers for what these actually are. And notice that there are 2 parameters here for EFI main. That becomes important later. We might get to that in a third ABI video. But for now, keep in mind that when it comes to registers, this is what it's talking about, assembly language registers. So, what are the 4 registers? Well, we've already mentioned it. And here it states it and lets you know again what we're dealing with. So we got RCX, RDX, R8, and R9. Go back to here and notice that that's what we're using here. This is a Microsoft standard. This is what the UEFI expects. This is the System V or System 5, what they're using. And notice that if we were to try to call a sysv interface or application binary interface from our EFI, it just simply will not work. So that's why you will see Linux community doesn't stick with the standards. They pretty much snub their nose at it. This is also why you would need the ELF format when it comes to using the actual sysv interface, because it's actually part of it nowadays. I mean, if you don't believe me, it actually says it somewhere in here. Here it is. Many of the advanced features, such as dynamic linking, are optional. Loading a simply static linking ELF program is straightforward. Let's see. I think it also mentioned. Here it is. It is today the standard ABI, as far as this is concerned, used by major UNIX operating systems such as Linux, BSD systems, and a few others. It says many others, but I say few. The executable and linkable format ELF is part of the System V or System 5 ABI. So this is why this has become a thing for the Linux community. Linux didn't start this, but they're the ones that made it popular. Hence why I attribute Linux to ELF format. We don't use this because we're going to be sticking with the standards, the Microsoft standards as far as the EFI is concerned, which is why you will find in our TUTs anytime that, go back here. Anytime in our TUTs, when you go to look at how we are interfacing, this is the ABI that we set up for our GCC. And this is why I use a Windows version of GCC that's compatible. Now, GCC's own version, and you've probably already seen the TUTs, Linux and Mac users can use the Microsoft standard, but they have to use a specific version of the GCC that's made for Linux and Mac, and you can look those up also in the EFI TUTs. Thanks to Dead Beef for creating the build information on how to use that. So, when it comes to standards, we have to make sure things align right. So, what are we talking about by alignment? Well, let's take a look at this right here. Well, that's not going to work. How about we use this one? All right, so let's say, for example, we have a main file interface. And int main, and you'll notice there's int arg, and then, of course, char, blah, 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 blah. But this is, if you take a look at this, it's 2 parameters. Now, ignore the fact that it's int and that it's char. The very fact is, it's 2 parameters. Same thing with void bubba a, int j, char b. It's 2 parameters. And over here, that means that this, calling this function over here, let's say this is a different file or binary, okay? This calling from this library or whatever, it lines up with these 2. But notice this only has 1, which means that this will not work with this. Well, it's the same principle. If you have one calling another, if the 2 binaries do not match in the parameters, on how many parameters there are, and in most cases, I think there are a few exceptions, but in most cases you'll notice like int as a type has to match int as a type over here. char as a type has to match char as a type. So they have to be identical in the ABI. Couple of exceptions is if you use a void pointer. We'll get to that in another time. That's irrelevant at this time. So with that said, because of the ABI standards and because of the way that we take care and interface, notice it's 2 parameters here. Hence, we're using these 2. We don't have to worry about these 2 over here. We're pretty much ignoring it. Now that brings me back to this here. In here, I mentioned number 22, if I may, and I think I put it here. No, maybe I didn't. Try the loader. Yeah, there it is. I mentioned this. So if you try to compile with just one parameter and you're not passing anything, although in this case we kind of need to because we're trying to grab a number, but let's say we weren't trying to do this. If you try to do this with one parameter, it actually will work. It's still within the considered standard. But if you try to only pass one parameter, that's not a standard because the Microsoft standard requires 2. 2, 0, 2, 3, or 4. But according to the sysv, it doesn't work like that. Okay? And the reason for this, and the reason that we use the 1 is because we only pull back one parameter as a return, whereas sysv has a return of 2, but has a connection or binary interface of 6 versus our 4. So when we go to align these 2 up, and this is why I'm bringing this up, when we go to align these 2 up, notice that they're shifted over by 2 in the format here. So that means that if you were to take a Linux program and try to line it up, well then these 2 show up instead of these 2. So it's out of alignment. They won't work with each other. Well, the company for the UEFI standard had to all come together and agree, hey, we need something we can use as an alignment, no matter what hardware we have. This is why the Microsoft standard had become the main convention, because RCX and RDX are guaranteed now on all hardware to work with these 2. Couldn't do it with the sysv because of these 2. So what did sysv do? Well, they pretty much snubbed their nose at this idea, and so they had to write in their ELF file format to change the position of this, to kind of redevelop this. It's a hack. It's basically a hack. It's all it is. Now, that's my opinion as far as a hack, but that's really what it boils down to. So this is why the standard conventions don't use this. And most all hardware can read and write this as the beginning because of registers. So, because here you shouldn't be using these 2 as a passing register. That's my opinion. All right. They should be for not passing. These 2 should be used as the passing, which I think others agreed, which is why this became a standard. So, alignment issues. And that's why alignment issues become a thing. Now, if you use this, then that means you're not guaranteed that your operating system is actually going to work correctly. And in fact, I know of a YouTube series that really doesn't work correctly. There are constant problems with it because they use the sysv. Using the Microsoft standard, though, you won't have these kind of problems creep in, because if you're sticking with the standard, that means you're guaranteed these 2 parameters to always line up. Now, in the next video, we're going to talk about what does all this have to do with files? Why do we need to worry about headers? Why are we messing with ELF header here? Why are we using this convention with this PE format? What's with the PE32+? Why do we even need the PE32+? Which, if you'll notice, scrolling down, there it is, and it represents this here. All right, well, we're going to get to that in the next video, and thanks for watching.